Hello and welcome to this OECD webinar with me, Duncan Crawford. Thank you so much for joining us. Today we're discussing whether students in some countries enjoy maths more than others. Does a so-called culture of mathematics have a big impact on the success of students? Well, OECD data show that no country has a specific love of maths, rather it's the policies that are important. There are actions that countries can take to get students more interested in the subject. We'll have a panel discussion on this in a moment, but speaking of interest, if you're interested in this subject and want to learn more than what we're just about to talk about in this webinar, there is a brand new OECD report just out called Maths for Life and Work, which outlines the different ways that maths is provided for in upper secondary education. It is very much hot off the press, out today, so you will be able to check that out. Now, though, let's get some details from OECD policy analyst Eduardo Magalhães from the Transitions in Upper Secondary Education team at the Education and Skills Directorate right here at the OECD. Over to you, Eduardo.
Hi, Duncan. Thank you very much for the kind introduction. Welcome, everyone. It's a real pleasure to be here. Just as Duncan said, before starting with our discussion, I'm going to give you what I will try to be it will be a short presentation, and I'll just share my screen with you. Can you confirm to me, Duncan, that you see the presentation?
Yes, we can see.
Okay, all good. So let's start the short presentation about this webinar, Understanding International Differences in Maths. So just a little bit of a short context before. This report that Duncan mentioned was originally commissioned by the Department for Education in the UK in 2023 under the former Conservative government of Rishi Sunak as a part of a policy that intended to increase participation in mathematics up to 18 years old. The former Prime Minister was worried about the relatively low participation of maths in England vis-a-vis the other developed nations. And he mentioned that England suffered from a specific anti-maths mindset that needed to be countered by making maths compulsory up to 18 years old. So in our report, that Duncan mentioned before, we look at the provision of mathematics in upper secondary in England and in 6 other peer systems. These were, just for information, Austria, British Columbia in Canada, Denmark, Ireland, New Zealand, and also Singapore. So it's important to say, obviously, since then, the UK changed governments, and this policy of making maths compulsory up to 18 is no longer in place. But nevertheless, the analysis that this report does has very interesting insights that I believe, and we believe it are very useful for not only England, but a lot of systems across the OECD and the world. So let's start about these big words that are cultural view of mathematics. There are a lot of depictions and connotations of mathematics in popular culture that can provide some anecdotal insights on mainly how people see and talk about mathematics and how children and young people actually hear about it and create their own perceptions. So this first one is from a report in England that talks about the views of mathematics, namely about parents. And this is a quote from a parent to a child that was referred as a standard attitude. And this, I believe this faithfully represents what the ex-Prime Minister Rishi Sunak mentioned when he talked about an anti-maths mindset. Another example, and this I found it particularly funny, but also in a dramatic tone of a 16-year-old. This is a title of an article from King's College London about how what the reasons why 16-year-olds do not continue studying mathematics. Further example comes from the USA in '92, I believe, about this teen Barbie doll that said this phrase, math class is tough. And I mean, obviously today we consider this very problematic, obviously as well because of the gender stereotypes it perpetuates. But I think it's quite telling about what was considered normal, at least at the time, in terms of the views of the discipline. And the last one, a more fantastic example, is from Japan in 2002, where there was a misunderstanding that in the context of some policy reforms, PE was being taught in school as being three, and this generated a massive turmoil in Japanese society, which is also an interesting contrasting example to the previous ones we saw. So there's like three main messages I want to take on from here before we go into the analysis itself. First of all, it's like cultural views of anything, but in mathematics in particular, are extremely hard to pin down. Second point, obviously, everyone has their own views of mathematics, and these are influenced by a myriad of different factors. And but the depictions that we do of mathematics and how we talk about in a society level are extremely influential on how younger people will actually perceive and deal with the discipline in their future. So moving on to our report, Mathematics for Life and Work, which was out since this morning, and I advise you all to take a look. We looked at a few things. We looked at outcomes of mathematics in upper secondary systems, the requirements for mathematics across the systems, how these different systems cater for different needs of students and their ambitions throughout different by providing different levels and options. As well, we discussed the cultural views and attitudes towards the discipline, and lastly, the influence that students, parents, and labor market perspectives have on mathematics. One important conclusion from this report is that we look at obviously the policies and how they shape the way students interact with discipline, and a lot of what might seem in the beginning as cultural views actually are as Duncan mentioned in the introduction, about public policies. So moving to this piece of data, in fact, an important insight is that there is no specific country or very few specific countries with what we call a culture of mathematics. Here we have some data. We look at enjoyment of mathematics 15 from a PISA survey and a primary school from the team survey, and also a self-efficacy index and participation. Just to give context, what is self-index participation? This is an index that was created in the context of PISA, and basically it's the student's self-perception on their capacity to solve problems of pure applied mathematics. I will give an example so people understand better. For instance, in terms of algebra, if students look at the timetable of a train, can they work out like with what time the table will reach certain stations? So what we see here is that when we look at England, it's actually above the OECD average and most of their peer countries on enjoyment and in the self-confidence index, but the participation is still quite low, and this poses like an important question for us to understand. But this is not just on the self-perceptions and attitudes, it's also on results. When we look here, the data from the mean scores of mathematics in PISA 22, we see that England is here on the right side on purple. By the way, purple is obviously England and the peer countries I mentioned before. We see that they do quite well. So it is interesting to see that actually they not only have positive attitudes, they do quite well, and still there was quite a low percentage of enrollment. One further data point here is a chart that looks at mathematics and numeracy proficiency between 15 years old in PISA and 24 years old in PIAC. Just to give the context, basically, this is an exercise that was done in an OECD report that harmonized the data of one cohort that did PISA in 2003, and then how these skills were evaluated later when they did PIAC in 2012. And obviously this is an harmonization of data, but this is not a longitudinal study, but still holds important conclusions. And the main message here to take is that a PISA at 15, although it's important, it's not the end of the line. And what happens after 15 in upper secondary education and in the early labor market interactions is of extreme importance to the development of fundamental skills like literacy in students. So we see here that actually across the OECD, these grew by 31 score points in this period, which is a very considerable value. And just by the way, the new PIAC data, although this one is old, will come out next month in December. So keep an eye out for it. So so if culture doesn't tell us give us the answer, then we look at the policies and like to explain maybe why England is so low. Such a low enrollment. And obviously here we talk about the the options and levels, and a diverse offer of mathematics in upper secondary education is very important to cater for students with different ambitions and different strengths. And we see these are is a very common strategy on British Columbia, Denmark, Ireland, and so on. A second option is a second factor is the vocational education, and either as a separate discipline itself or integrated on other disciplines, it is a crucial strategy for many systems to make sure that all students acquire the mathematical skills they need. And Austria and Denmark are very, very successful examples of this. Third point is obviously making it compulsory, which is not in the UK after 16, but is the case, for instance, of Austria as a core subject of the program curriculum. But it's important to say that although making it compulsory could help, it's not necessarily the answer. And we have systems that why they don't have it compulsory, they have near universal participation, which is the case of Ireland, Singapore, which connects my next point to the higher education about the tertiary requirements that can work as a powerful level. For instance, you might not have it as a mandatory, but if all universities, all higher education institutions require you to have it, in practical terms, people will have to take it, and this can be an important factor. Just moving on towards the end of presentation, I wanted to go back to my first point of diversity, which is really important. As you can see here, that nearly all systems provide mathematics at different levels and options. And we see on the x-axis the number of options provided by post-secondary systems, and on the y-axis the number of levels. And here we see that England is highlighted for having a particularly low diversity year. They do offer core mathematics as an alternative to the A levels, but obviously there is some problems, and the take-up was really low. We discussed in the report some of the challenges. One of them was actually something we mentioned before, that tertiary education institutions were not valuing this discipline. But basically, what are the consequences of this is what we want to discuss. And the lack of diversity has the risk that mainly the upper secondary programs on disciplines will not cater for all students, which brings me to my last point here, which is basically A levels mathematics. Just for a little context, in England, the upper secondary education system is divided into stages. From 14 to 16, we have what they call the GCSEs. Then they take these exams, and then after 16, they can pick three A levels to do up until 18. Being mathematics is not mandatory after this transition at 16-year-old. And here, to explain just this graph briefly, on the x-axis we see what are the grades they have at this exam at 16, the GCSEs, being 9, the grade 9 is a higher grade. And on the left, on the y-axis, we see the progression rates from this GCSE stage to the A levels according to the different disciplines we're talking about. And if you look at this chart, you can see that mathematics, that is here in this blue-greenish color, we see that the line is very flat on the lower grades, and then becomes extremely steep, which means that only the high-performing students in mathematics are actually enrolling in the A levels of mathematics. To give a bit of information, what a grade 7 to a grade 9 is equivalent to an A or A star in England, which means that the consequence of this, only very, very high performing kids are doing this. If they don't have an A, they won't be taking this. So there is a lack of options, mainly for non-high performing students that could do mathematics, could be doing it, but they don't have an option that works for them. Just as a plus, this is also visible on the distribution of grades. When we see in England, we see that when we see the A levels grades of different disciplines, in mathematics is only the distribution reveals that most people have very high grades, which reflects obviously the selection bias of whom enters this discipline, and this contrasts with other systems that have more options, more levels, and where the distribution is flatter and more equitable, which is the case of Ireland. If Linda wants to touch this point later on. So with this, I conclude and apologize myself for going a bit over time.
Thank you so much, Eduardo. That really was very interesting indeed, and also interesting to see the drop-off in students who like mathematics when they're primary age, but how much it drops off by the time they're 15 years old. There is a question from Kaori Miyamoto, who's asking about the former Prime Minister Rishi Sunak's pledge to make all children learn maths until the age of 18, asking, is it the UK or just England? And it is just England. That's because education is devolved in the UK. And of course, now the Sunak Conservative government is no longer there. They lost the election, so there is now a Labour government in the UK. So thanks for that question. And please, to everyone else, please write in your questions and we will try to get through as many as possible. Now, though, I think it's probably a good time to introduce our panel without further ado. So Hjalte Milvang is joining us. He's Senior Advisor for the National Agency for Education and Quality at Denmark's Children and Education Ministry. And Linda Ramsbottom is also joining us. She's Senior Post-Primary Inspector from Ireland's Department of Education. Thank you both so much for joining us. I want to start by talking about ages and mathematics, because maths and numeracy are clearly an important part of education. But until what age should children learn mathematics? Obviously, the former British Prime Minister said the age of 18. Hjalte Milvang, what do you think?
So the short and politician's answer would definitely be that depends. And so, I mean, obviously mathematics is important for most people, right? It's instrumentally important for many jobs. It's a requirement for doing further education, but it's also something that's useful in everyday life. We all need to be able to do our budget. We all need to be able to understand why it's a bad idea to borrow money at a really high interest rate. So obviously one shouldn't end mathematics too early. But what the exact right age would be, I think is a difficult question. I think empirically looking at Denmark, we can see that we've had a change over the past decades from a system where the mathematics education that we would do in our academic upper secondary track would be geared towards mathematics as a science discipline, towards more of a view that, well, really and then those that chose not to do, and then that level could be really high because it was a smaller group. But then with the for like 20 years ago, 15, 20 years ago, there were definitely changes in how we did our academic track in upper secondary, so that much more students, like a greater number of students now probably study mathematics, but then perhaps for some at least at a lower level, because the types of students that used to not study mathematics now study it. And that reflects also, I think, a change in mathematics is important for everyone. So one shouldn't end mathematics education too early, but it's definitely impossible to say whether 16, 17, 18, 19, 14 would be the right age.
Just a quick follow-up for you, if you don't mind. So you said now there's more children who are studying it to a later age. Do you get pushback from certain young people who say, why should I be studying mathematics? I'm not interested in it. I know you're telling me it's important, but it's not something which I think I want to pursue in the future or is necessary for whatever career I want to do.
So luckily, I don't think the young people are aware of how they're impacted by reforms done 15 years ago. So we definitely don't get the pushback in that way. But what we definitely do get is that the more varied student population you have in a given math problem, the harder it is to teach, right? It's easier to sit down with 5 PhD students in mathematics and discuss something than it is to introduce a class of 25 people with different entry levels in mathematics. So it is definitely the case that people's prior experience with mathematics and motivation for being in class would definitely have an impact. That's something we hear from teachers for sure.
Okay, I see. Thanks so much for that. Linda Ramsbottom from Ireland's Department of Education. Let me bring you into the conversation. What is the situation in Ireland, actually? Do all students study maths up until the age of 18?
Good morning, everybody. Thank you. Yes, in Ireland, we have compulsory mathematics up to the age of 16. So that's lower secondary education in Ireland. And then after that, we have a couple of different ways students can access mathematics. While it's not compulsory, it is technically compulsory because the majority of students will take mathematics to gain entry into further education, so into third level, or they may also want their mathematics to enter the workforce or a trade. So after our junior cycle, which we call it the first 3 years, we then have a track which we call the Leaving Cert Applied. About 3,000 students out of a small proportion of our students take that option, which would be mathematical applications, they call it. It's very practical. It's not geared towards getting you into university, although you can eventually move into university or third level education. It's more practical course the students would follow for 2 years. The traditional Leaving Cert, we would call it, is broken up then into 3 different levels. So students can access a level then appropriate to their needs and abilities. So technically, while it's not compulsory, we have retention in Ireland for students from first year, lower secondary, all the way to their final upper secondary is over 90%. So the vast majority, 98% of students would follow some level of mathematics in Ireland.
And if you having so many students do that, some 90%, does that have an impact which is quantifiable on the economy? Do you see it have a positive impact on jobs, or is there not data to show that?
Yes, we do have some data to show that about 120,000 Irish people would be involved in STEM careers, and about a quarter of them are females. And we also have statistics to show that over the highest level of STEM graduates per capita, we would have between the 20 years of age and 29 years of age in comparison to Europe. So we would have a kind of, I suppose, a population who would be highly qualified in the area of mathematics. We have a lot of industries that come into Ireland, in the pharmaceutical industries and other those kind of industries that would require mathematics in Ireland.
Thank you for that. Eduardo, let me bring you back in to discuss some more about the international data. Is there any data that shows it's important to teach more complex mathematics until the age of 18?
Yeah, definitely. I think there is strongly evidence to support that it's important to teach mathematics during the upper secondary, and has implications not only for individuals but also for society. One of the first things I wanted to mention here very briefly is that it's not only about mathematics but also numeracy. While mathematics deals with things as geometry, algebra, etc., numeracy refers to the practical ability to understand these concepts and apply them on real life situations. And these things are interconnected. Many times people would wonder, oh, why do I need this certain content from the mathematics program to my daily life? But the problem is it's not only necessarily by this content per se, but about the skills that this gives to the students and how they can apply them then in their lives. And this goes to goes from things to financial decisions to health decision, etc. And particularly, I wanted to say about the role of upper secondary. It's very often the last stage of formal education people are in contact with, and it's just before the transition to adulthood, where people many times will need these skills, these numeracy related skills, to make decisions in very, very complex decisions in the real world setting. But in terms of data, because you mentioned that there's some financial data. We know from many studies and studies in the UK particularly that low numeracy skills are related to poor financial decisions. And there was one study in particular that says the annual cost of around £460 per year on individuals that have low numeracy skills. But also, like in employment and earnings, we have some data from the OECD, from the PIAC survey of adult skills that I mentioned earlier, that people with high numeracy skills are more likely to be employed and earn per hour up to 13% more than their peers with the lower numeracy skills. And not only that, but we actually see that this impact on employment and earnings is higher when we compare the difference in numeracy skills than actually the differences in literacy skills. So it's actually very important. But also at a societal level, I want to make a last point. It does affect productivity, national income, social well-being. There was another study in the UK that mentioned more than £20 billion per year of losses coming from low numeracy skills that a lot of people, a percentage of young people had in society, and this is equivalent to 1.3% of the GDP at the time. And this also brings the question of equity and distribution of skills. A lot of times, people that come from more unprivileged backgrounds actually are the ones that are caught on these perpetual cycles of disadvantages and having lower numeracy skills, not reaching the opportunities, not reaching the best paying jobs, and actually cannot break this cycle. So it's really important to increase the social mobility, to restore the social elevator, but also to respond to a diverse and high skill demands of today's economy. So just to tell you, like where like for example we see in PISA level 2, it's what we call the minimum proficiency in mathematics is important. We need more, and this is what the data from PIAC that I showed earlier meant to tell you is precisely it matters what happens after 15. It matters what happens at the age of upper secondary education and even perhaps further. So it's extremely important that yes, students do take this discipline and acquire the numeracy skills they need to lead successful lives.
Thank you so much for that, Eduardo, and thank you to everyone who is sending in comments and questions. Hi to Rachel from Bristol saying hello, greetings from Australia, from Karina, Mikkel in Denmark saying hello, and there's a question from, which has just jumped off my screen, from Yvonne Elliott. So I'll pose this question, I think, to who's probably best. Hjalte Malvang, I think, is probably best for this question. Yvonne Elliott asks Hjalte, do you think mathematics is taught in a manner that allows students to appreciate the need to learn mathematics?
I'm not sure, but I was thinking about whether it should be like that, whether we want, students to learn mathematics or indeed learn anything, at least if we're talking about primary school children, because they feel the need to do it. I mean, when children enter school at 6 or 5 or 7, they are sort of little learning machines, right? They want to learn. They're really, really curious about the world, and they want to learn about reading. They want to learn about numbers. They want to learn about the world. And then for whatever reason, we managed to make them less interested in learning. I think Eduardo's report showed this really well, that when you have those international assessments that can that have a measuring point both at 4th grade and 8th grade, you see that the children are generally less, or the young people are less enthusiastic about learning mathematics and other subjects when they're older, which I think is one of the major problems we have with education in general, and perhaps mathematics in mathematics specifically. So I don't know whether it's the way we teach misses out because we don't manage to communicate to students why mathematics is important, or whether we fail for making it as engaging or interesting as it should be. But I would certainly agree that there is something about the way schooling is set out and the way that mathematics is taught where we seem to be losing children along the way, and that's certainly not good. And we can see this also moving, beyond lower secondary into all the different tracks that all our countries have in upper secondary, that the experiences that the students, the young people have had with mathematics previously certainly have an impact. Let's say the more vulnerable student group we work with in our national education system, I have talked to teachers saying, we really need to, before we can even get into teaching mathematics, we need to, remove from them all the bad experiences they've had with being taught mathematics previously. And I mean, that's certainly important. And I mean, most of those experiences are experienced in primary school. So there is something about how mathematics is taught, whether it's mathematics specifically or whether it's something in general with our schooling model, I don't know. But we certainly have challenges on retaining motivation as children grow older, whereas very few people have a problem with maintaining the motivation to learn of 6 years old and 7-year-olds, right? I mean, that's just not a problem, but it increases as they get older.
Thank you so much for that. And just a quick follow-up for you, if you don't mind, because what kind of maths are we talking about when you're teaching older students in Denmark? Is it understanding how to do more complex equations, for example, or is it giving young people information on how to understand things like mortgages and car loans? What sort of maths are we talking about?
Well, it depends. I mean, so for the end of lower secondary, right? So the last stages in which everyone basically follows the same track, you know, which you do until you are 15 or 16. I mean, there are more formal math than there is when they're younger, but there is also an emphasis on applied math. I think, you know, the idea of mathematical competencies, which is basically that you should have some skills and you should apply them to the real world. I think that's very strong in the Danish curriculum for a lower secondary. Then moving into upper secondary, it depends even more because, you know, there are different tracks, right? I mean, there are the general academic upper secondary, what we call gymnasium in Denmark, following sort of a German tradition. And even within that, there are different tracks that you can choose from, and some of them go more towards mercantile education, something more towards technical education, and something is just more general academic. And in all these three, you know, mathematics is supposed to be different. But of course, once you finish what we call A level or mathematics, I mean, it becomes, especially to general academic, it becomes quite theoretical academic, but of course, always with an emphasis on, you know, it should be used for something. It shouldn't just be for its own sake. But then you have a completely different track in upper secondary, which is vocational education and training, where you essentially train to do a specific profession, right? You train to become a carpenter, or you train to become a something else, right? A technician of some sort. And I mean, the majority of sort of the technically minded professions will have some requirements for math there. And there, the curriculum for the math studies you do will always be geared towards the profession, right? So to the greatest extent possible, the teaching should be done with examples that are relevant for the work. And that's also because students in the vet track are often in the vet track because they wanted to study a profession, not because they wanted to study mathematics per se. So it's important to keep motivation and engagement that also math class seem relevant.
Thank you so much for that. One of the key questions that OECD report was looking at was if there's a predominant culture towards maths in different countries that can influence the success of policies. Linda Ramsbottom from Ireland's Education Department, you're an inspector, so you're probably going in and out of schools, meeting teachers and students and so on, even maybe parents. Is there sometimes an anti-maths mindset among those who you meet in Ireland?
Yes, I suppose my role as an inspector, we're part of the division of the Department of Education, and we have a dual role as such. We have an evaluation we started early years, so from about 3-4 years of age all the way through to 18-19 years of age. So we've inspectorates for each of the different sectors. And we would regularly undertake a variety of inspection models, and we have announced and unannounced inspections. And during the announced inspections, we would often have focus group meetings with parents during our whole school evaluations. And we'd often have then during the regular inspections, subject inspections, in particular mathematics, or program evaluations. We have a number of programs that we offer in post-primary. We would have a number of meetings with the focus groups of students. We don't like to call ourselves anti-math, but we call it the perception of their ability. And it was interesting when Eduardo put up there about the little, you know, what the child said about their own understanding of mathematics. I was never good at it. You'd often hear parents saying, I was never good, so I don't expect my child to be good at them. Or the child themselves would say, my brother or sister was always better than I was at mathematics. And sometimes there's a gender difference there as well. More recently, in the last couple of weeks, we've started a project where we are looking at the transfer from the upper post-primary school into the first year, second year in post-primary, and looking at with a specific focus on mathematics. And we call these they're announced inspections for incidental, so it happens in an incidental model. And we're talking to children, and it's really interesting listening to their voices and the kind of the motivation that they have. And already they're having preconceived ideas. So that mindset is set nearly before they even enter the post-primary, lower post-primary, and then that'll manifest itself as they go through. I think kind of come back to what you were talking about a few minutes ago. well, we don't call it anti-maths. We think it's kind of a perception about their abilities. And I suppose looking at it, are they motivated to learn? And in Ireland, I suppose we can see as they move in to the teaching practice that they engage with, they'd often say to you in sixth class, when I go into first year, the lower secondary, it's going to be a repeat of sixth class. When I get into second year, there's a jump in my education. It's very different. And then we're ready for our first high stakes exam in the third year in lower secondary. And that determines sometimes the approaches, the methodologies that are engaged with during the classes. So it can be once you get to high stakes, we find sometimes at the inspectorate, we would see that teachers' pedagogies change. Maybe sometimes it's not as engaging. It's more, take it down from the board. Let's make a note of this. Do the next one, do the next example, do the next question. So I think pedagogy does have an important influence on what happens. Also coming back to something Eduardo said there, in Ireland we've had significant change in our curriculum. And I suppose in 2009, we had a literacy numeracy strategy. But coming back to numeracy, in our new curriculum for junior cycle, the first 3 years of lower secondary, we've now have key skills, and we're looking at moving from a kind of a content-based curriculum to a more skills-based. And one of the key skills we have at junior cycle would be being numerate and what that entails. And moving into our post-senior end, our upper secondary, we're now looking at revising our curriculum for upper secondary, and we're talking about key competencies. And we've wrapped around key competencies, we've 8 key competencies, but the main focus ones are literacy and numeracies again. And in each of the curriculum specifications that are being designed, those key competencies must factor into how the curriculum is designed. We've done it at junior cycle, lower end, but now we're moving it. So numeracy is quite a strong feature in our mathematics, and ensuring that everybody has the ability and the skill set to implement it in no matter beyond mathematics in other curriculum areas as well. So it's quite an interesting link that Eduardo has made as well between mathematics and numeracy and what we've done in Ireland. So we're still under a pathway of change, significant change. Our primary curriculum is changing. Our early years curriculum and framework that we use at Ashton is changing also.
Thank you for that, Linda. If I can bring Yalta back in on the question of an anti-maths mindset, is that much of an issue in Denmark or not?
I think I would say much the same things Linda said, right? Indeed, building on what I said before, that in many ways, mathematics might be an unforgiving subject, right? I mean, at least it's perceived as such, that just to say it really, really, really simply and probably too simplistic, but an equation is either right or wrong, and making quite a few students scared of mathematics, right? It's harder to just venture a guess, or indeed having a discussion about, let's think about this problem mathematically, because many students think that mathematics is not something you discuss, right? It's not something where you reason together. It's something where you calculate and then you have a right or a wrong answer. And that's not, what we're looking for in our curriculum, because we actually want students to be able to see, well, we have this real life problem. Let's translate it into mathematics, and then let's do some calculation. Then take the results of the calculations and translate them back into real life. And that's not often understood. It's more the precision of mathematics is often what people take away from it. So I wouldn't say anti in the way that people have a coherent, opinion where they don't like math. It's more that I think the quote that Eduardo had on his slide, mathematics is just not for me, or I've had bad experience with mathematics in the past, is deeply ingrained in some students who might also have had, parents saying exactly as was also on that slide, mathematics, we were never good at mathematics in this family. And I think, these kind of reactions, you can get that with students that have had bad learning experiences in the past. You can get them in any subject, right? It's also really, really, really prominent when you try to do dyslexia teaching for adults that have just where reading is almost a traumatic experience. But I do think even though you can get it across the board of subjects, it's prominent in mathematics. So it's not an I wouldn't call it a culture in that, it's not like the quotation from Rishi Sunak where there are something in our culture where we dislike math. It's more that, particular the more micro level engagement that students have had earlier on in their learning careers with mathematics have made them, like that subject less. And then, that's something you need to work on.
A quick follow-up for you is a question from Kwan, who's talking about the rise of AI and other technologies that can easily solve maths problems he's talking about. And in a world of AI where you can ask a computer to work out almost anything, specifically everyday maths questions, how is that impacting the teaching of maths, and does maths need to adapt?
So as I understand it, AI is a language model. So it's actually much worse. I think the OECD did a project where they tried to make artificial intelligence work on different things. And in general, they are less good at math than at words. Traditional computers are good at words. The sort of large language models, they're good at words, not numbers, which is why they're interesting. Anyway, so of course, the society we live in impacts how we should do. I mean, if for no other reason as education systems, we need to engage with AI because it challenged our examination model. Perhaps less so in mathematics than in other subjects, but in Denmark, we have sort of like long form written assignments is quite typical of how we assess. And I mean, that's obviously the most AI vulnerable way to assess. So we need to take account of the fact that students will probably use AI whether we want them to or not. So in that way, we should adapt. But I mean, at least personally, I don't think it's at least currently, I don't think there's any need to revolutionize how we teach, or that there are any of the skills and competencies that we think are important. None of those competencies have become less important with AI. I don't think so.
Thank you so much for that again. And I'd like to, for a moment, if we all agree, or if most people agree watching this, that it is important for young people to learn maths to a later age, to 18, for example, as suggested at the start of this webinar. How do you go about doing that in practice, particularly for other countries where it might not be the same approach? Linda, what approach does Ireland take?
Yeah, we have at the upper senior cycle, we have, we call it a senior cycle. After our 3-year compulsory education up to the age of 16 or thereabouts, students can have the option then of what we call a 1-year transition program. So there's a 1 year where students, it's an optional program, and they can opt in or opt out of the program if the school offers it in their school area. And that would actually allow them to continue on with their maths education in some format. It doesn't have to be formally. It could follow some aspects of the curriculum for senior cycle, but it shouldn't always be in the full curriculum. And then after that year, you have the 2 or 3 further options. We have what we call the Leaving Certificate Established, and that offers 3 different options to the students. 3 different levels of mathematics are offered in that Leaving Cert Established. We have a foundation level, which really caters for students' abilities who may want mathematics for everyday life and may not want to go on to further studies, but may need it as an access point to maybe a trade or an apprenticeship. We then have what we call the next level up will be ordinary level. And in the ordinary level, then that will be geared for students who are dealing with kind of abstract, they're starting to begin with abstract ideas. And they would access the 3rd level education at a different level to what their needs would be. But the higher level then is the top level we would have in our final 2 years of examination. And that is geared towards students who want to progress their further studies in mathematics or other disciplines associated with mathematics. And that will be developing, I suppose, the powers of abstraction and generalization. So they're the kind of traditional established Leaving Certificate. The Leaving Certificate applied then is a standalone 2-year program. However, more recently, that has we've allowed the students who are taking the Leaving Cert Applied program to access the Leaving Certificate Established Mathematics. So they can opt to do their Leaving Cert Applied Mathematics and or follow the ordinary level or higher level or foundation level, depending on the school. So we have a range of options available to students. So we don't just, after the junior cycle, that's it, you don't have options. There are 3 more levels that they can continue on with. And I suppose after that, we would, we also offer, for students who take the higher level program, the higher level option, we've brought in a bonus points, we call it. That's purely for students who want to go on to 3rd level. So they get an extra 25 bonus points, we call it. All of our students who sit their leaving certificate receive, based on what award they receive, a H1 or whatever it is, they receive points, and an additional point is added on for higher level mathematics, not for ordinary level, not for foundation, just for higher level. So I suppose they're the kind of ways, the curriculum ways that we can support students.
Sorry, thank you very much. I need to unmute myself. A quick follow-up for you, actually, because it's a statement from Erzabet Pastor on the chat, who says, my experience is that people think that being good at mathematics is a question of talent and not of hard work. This is a serious problem if teachers reinforce this impression. What experience do you have in Ireland related to that kind of issue?
Yeah, I suppose from my perspective, being in and out of classrooms, we can see that there are some teachers who would perceive that a student, if they're talented, they're excellent, they'll be very good at mathematics. It's not always the case. You will see students who would try their best and work hard and will be quite good at mathematically. I think sometimes it's their motivation, I suppose their exposure from an early stage of, as we've already spoken about, I suppose, that need to kind of tease out questions, talk through the possibilities. Not just one answer is the only answer. And maybe, yes, there are talented kids who are quite good. They will get to an answer without even thinking about or writing anything down. But some students have to work through a process. And I suppose it's the ability of a teacher to understand that some students have the ability an innate ability to understand in a different way, and that not one approach is the only approach. And I find sometimes in my inspection work, we can see that it has to be the teacher's way to do the question, and not allowing for the creativity amongst the students and understanding and teasing out, why did you say that? Is there a misconception here? And using that misconception to develop a student's understanding of what's happening in the maths classroom. So I think you are right. I think talent is always misunderstood as being very good at mathematics. It can be hard work that you need to think about it, work through, and see different problems in different ways and in different contexts.
Thank you so much. I want to bring Eduardo back in to get his reflections on some of the past few comments. Also, there's loads of stuff going on in the chat. Apologies right now. It's moving so quickly, I'm actually struggling to read it. But yeah, Eduardo, if I can bring you back in, what are general approaches that the OECD is taking, or OECD countries, I should say, are taking to encourage people to stay in maths?
Yeah, so building on what Linda was talking about, it is very important to understand that in mathematics, and particularly in fundamental disciplines like mathematics, there is individual development rates, and not every student does develop it like at the same pace. So I mean, while for instance some students might have great skills at 15, many do need like after 15, 16 to solidify this fundamentals. So I think the main conclusion we take by looking at the different OECD systems is the importance of flexibility. A lot of times when there is no flexibility on how we provide mathematics, how we teach mathematics, we might get students stuck in certain milestones and then experience problems of cycles of repetition, of dismotivation, of this sense of failure. And this is more on the policy side of the provision of mathematics and the assessments. Actually, there was a comment from, I believe, Elizabeth that mentioned the resit and GCSEs, and this is actually a great example to bring this discussion, because in England, for instance, when we saw at 16 when students take the math GCSEs and they don't achieve grade 4. When they don't achieve at least this grade 4, they need to take these resits, meaning they need to, after 16, continue to try to pass. And a lot of times, they just get stuck on this cycle of repetition of doing the same thing over and over again, which might imprint this sense of failure, the motivation, and also create this fear of mathematics, this horrible thing they cannot get rid of. So it's an important policy question if the one size fits all policy is actually the most effective approach, and indeed it is not. We need like a diverse range of solutions. What Linda described as the Irish case with the different levels, or even we know also from Denmark there is diversity, are definitely very important strategies to do this and to make sure that we have a tailored offer of students on how according to their strengths and interests. But the main point here, I will say again, because it's really important to say this is a diversity, and there are also other ways. For instance, I want to bring in the example from Austria, which is one of the peer countries. Although, for instance, Austria only have one mathematics option in each program that is mandatory. There is a variety of programs. Austria offers many programs, and in particular in the vocational sector, it's an extreme rich sector in which they have mathematics taught in different forms, in many cases applied as well in different subjects. So mathematics is imprinted on the way they teach some trades and some other subjects, and this is extremely important because it provides a diverse range of pathways and it guarantees at least that students can deal with mathematics in different ways and not only in one, which is important for their success and for their engagement. So yeah, I would say definitely this is one of the main messages we wanted to bring, is to one size fits all policies normally don't work that well, and try to be open to cater for different students.
Thank you very much, Eduardo, and thanks for all the messages coming in on the chat as well. I'll quickly run through a few of them. Voldemir writes, excellence in maths is a gift from God, which demands hard work, but maths for every day is a result of hard work only. In contrast, I'm trying to zip down here, Vesna writes, mathematics is not only talent, but also hard work, and it's needed to develop logical thinking in solving problems. And there are loads more comments as well, but we really don't have time to go through all of them. Hjalte Malvang from Denmark's Children and Education Ministry, if I can bring you back in, because I want to talk to you about student perceptions, which we did touch on earlier on. Denmark does comparatively well in maths, to those who don't know, internationally. But when you look at student perceptions, there is quite a big drop-off between primary and secondary schools, and the decline's pretty big in Denmark. We see this trend in lots of countries, but the decline is pretty steep in Denmark. So why do you think that is, and is anything being done to try and combat that?
So I think I spoke to that earlier, right? That there seems to be a general problem with children being more motivated to learn than younger than older children, and then older children becoming less motivated as they go older. So I mean, I don't think we have any particular policy on sort of like, say, the stage where you move from upper secondary to lower secondary on, but it's definitely a part of our general, let's say, problem description. A couple of years ago, we had an expert group on mathematics across both basic education and upper secondary and all the tracks within the upper secondary that's tried to look at a holistic picture of mathematics teaching in Denmark. And this issue that you're talking about with students being disengaged is definitely a part of that problem, especially because it means that it's, I think I'm repeating something I said earlier, but it's harder to teach a class where you have not only a variation in skill, but also a variation in motivation and a motivation in self-efficacy. So especially for our VET tracks and also our tracks for those that didn't find an easy path through education, there are quite a few students there that really have this mathematics was not for me mindset. And that's definitely something that you need to address. And I think that's probably addressed best by using different strategies in the different tracks of education, because you have different students. So in the sort of more practically oriented VET track, I think it's one good way of addressing motivation of students is to show how mathematics is relevant to the profession that they are there to learn. I mean, they're motivated to train that profession that they elected into. And we then think that it's probably good for them to have some general mathematics as well, but that general mathematics should be taught so that it's always clear to the students that it's relevant. Then if you go to academic upper secondary, where students, or at least some of them, should be prepared for study in the sciences, physics, mathematics, chemistry, where you kind of need abstract, advanced mathematical skills. In that way, it's probably okay to focus more on mathematics in its own sense. So I mean, I think it's just as most countries in the world have more differentiated education systems after the age of 15, 16, right? And I think the solutions for this, for how to teach math best, is probably to build on whatever was built into your system and then tailor the teaching of math to whatever track the students are in.
Thank you very much. Linda, if I can bring you back in on the subject of lifelong learning. We focused a lot on students, and then Yalte there was just explaining differences between primary age and the age of 15-year-old. But what about adults? How do you engage or re-engage adults in maths so that they're better equipped to deal with societies which are becoming more complex, with more complex data and more complex technologies?
In Ireland, we have a dedicated support service. We call it's IDA. It's like teacher. It's an Irish word for teacher. It's a culmination of a number of support services that we've had over a number of years. Traditionally, they would have had an opportunity to engage with teachers through a variety of different supports, and now it's merged into this one dedicated support service. And I suppose in terms of mathematics, we have IDA provides a support service in terms of 1 day release from school. So teachers of mathematics, when a new curriculum is established, they have a number of days, usually 1 or 2 per year, and the teachers would access that. In addition, then the support services also have worked on initiatives, what we call numeracy deep dive, where the mathematics teacher will collaborate with, and we call it a carrier subject. So would say maybe geography or something like that would have a level of mathematics in it, and it kind of promote numeracy in the classroom and promote good mathematical skills and competencies throughout the system. So you have a peer working with you, so your colleague will be working with you to develop your numeracy skills, but also to support the consistency in approaches and language that was used in the mathematics class into other discipline areas. Okay. We would also have out of field support. So teachers who want to come back in and re-engage as a mathematics teacher. The department has funded since 2012. We've had 2 versions, 2012 to about 2018, and 2019 then it started a second phase of this support. The department will fund upskilling of teachers who want to come back into the education system, who have a degree but are not mathematics teachers. And that has helped us to a certain extent with supporting the lifelong learning of teachers in mathematics.
Thank you so much. Look, we are almost out of time, but I'm going to do a quick fire round with our panelists just before they go. And thanks to everyone again for sending in your questions. So Yalte, I think I'll start with you. If there was one suggestion for a priority action that countries could take to make maths more appealing to more students, if we're talking about this culture of mathematics, what priority action would you recommend to make maths more appealing to more students?
I think it's probably important to make sure that students have early on the right foundation. So focus on letting what we in Danish call number comprehension, which is the basic algebra, that then too many students miss out on that. And then that just haunts them for the rest of their education system. So sort of teaching them the most important, most foundational stuff early on, and then, kindling the flame and keeping it alive by not making them experience defeat after defeat because they missed some basic stuff early on would probably be very important.
Thank you very much. And Linda Ramsbottom?
Totally agree. And I suppose we have a policy now that our literacy, numeracy and digital literacy strategy, if I can get all my strategies out here, we had initially was in primary and post-primary. Now we've brought it back to the early years settings as well. So we've included the early years settings with numeracy. So developing that love and that fun and the sense of achievement at an early stage, and developing it through practical, real life experiences and the continuity, appropriate continuity, and teasing out those questions with kids. That's what I would recommend if I could at all. Thanks a million.
Thanks so much. And last but not least, OECD policy analyst, Eduardo Magalhães. What do you think? How do you make maths more appealing to students? What's the one priority action you'd recommend?
Well, our work is mostly on upper secondary education. And Yalta and Linda already talked very well about the younger ages in the primary. But I would like to say that at least at the upper secondary education level, it would be important to adapt to needs of all students. Regardless of their previous experiences, we should build diverse pathways to make sure they actually can many times catch up. They can change their perception of mathematics, and they can build the skills that actually they need for the future and to keep the doors open. So again, I wanted to underline the question of option levels, also some bridge programs. This focus on not leaving anyone behind despite any negative experiences before, I think it's the central point I want to make on now to improve the relationship with mathematics.
Thank you so much to Eduardo from the OECD, of course, also to Hjalte Malvang from Denmark's Children and Education Ministry, and also to Linda Ramsbottom from Ireland's Department of Education. That is it for now, I'm afraid. Thank you to the production team for all their help behind the scenes, and thank you for tuning in for this OECD webinar. We will have plenty more of them in store for you right up until Christmas. Please do check out the new OECD report, Maths for Life and Work, which this webinar has been based on. You'll be able to learn much more about what we have discussed. The link was shared in the chat. Also, please do also check out the OECD Education podcast, Top Class, which has featured various episodes on mathematics, including a chat with the US Teacher of the Year, who happens to be a maths teacher herself. That's it for now. Hope to see you for another OECD webinar soon. All the best.